So this is hopefully going to help you understand motion maps a little bit. Again, motion maps are a way of qualitative way to look at motion. So in other words, it doesn't involve numbers. It's simply a way to get a grasp of what's happening without numbers. So what we're going to do, one of the key things is we're going to shrink everything down to a particle. So I don't care what it is. I don't care if it's a person. I don't care if it's a car. We're going to represent it by a dot. So here's my picture of a kid on a bicycle. Here's my picture of a kid running. Here's my picture of a 18-wheel truck. Okay, we're going to shrink it down to a particle. And what we're going to do is we're going to show how something moves based on that. So let's do an easy one. Let's say Julie walks at 1 meter per second for 5 seconds. Now, in order for us to have it, we have to have a reference point. This is my origin. This is my starting point. I get to decide where that's going to be. I also get to decide what positive and negative is. Our convention, we'll stick with what the math teachers do. That's positive and that's positive. Because direction does matter in this course. Okay, and then what we're going to look at, I'll make a dot for every second. I'll make a line. Okay, now, so we're going to take a look at exactly what's happening. Now, I didn't tell you anything about where she started. We're just saying she walks for 5 meters per second. So 1 second later, she's going to have moved 1 meter. So she's going to be right there. Another second later, she's going to move another meter, and she's going to be right there. A third second, she's going to be right there. A fourth second, she's going to be right there. And a fifth second, she's going to be right there. Now, so what this almost is like is taking a picture of her with a strobe light, where I'm only worried about where she's at particular times. The next thing I want to do is I want to draw a little arrow on there to show which way she's moving. Now, I always draw the arrows less than the distance between the dots. Generally, we'll kind of use halfway between it. But we are going to kind of vary it based on length. What I'm going to do is I'm going to say that. I'm going to draw that. That's going to represent her speed. That's going to represent, well, technically, I guess it represents her velocity, because it's telling you she's going to the right, which is positive. And that would be a motion map for that example. It simply shows that she's moving, and each unit of time she's moving at the same velocity. Okay, let's do another example and see if we can make sense of this. Now let's have Brandon, occasionally lazy. Brandon stands still for 5 seconds. So in other words, let's see what would happen if you were at rest. Again, we'll start with this, put marks like that. And again, this is an X thing, this is an X thing, it's showing position, and we're going to make them standing still. Let's make them standing still right at what we call 0. We'll call this 0, and he's standing still. So there's Brandon. Brandon's standing still. 1 second later, Brandon's still standing still. 1 second later, Brandon's still standing still. 2 seconds, 3 seconds, 4 seconds, 5 seconds. He never moves. I don't put any arrows on this because he's not moving. He's standing still. So, in other words, I can't just make one giant dot. I need to be able to show different dots as he moves on. So that's Brandon standing still. Okay, let's try one that's maybe a little more complicated. Let's do this. Let's say Brandon then gets over being lazy. Brandon stands still for 2 seconds. Then walks, at 2 meters per second for 3 seconds. So again, I'm going to call that point 0. I hope I put enough hash marks on there. We'll have to check. So what I want to do now, again, this is my positive. I think it's a helpful hint to draw this right there on there. Let people know what your assumption is. We'll say this is our starting point. Okay, that's Brandon at 1 second. That's Brandon at 2 seconds. This is Brandon at the 3rd second. Okay, so he's standing still for 2 seconds. Now the 3rd second, he's walking at 2 meters per second. He's going to be here. At the 4th second, he's going to be here because he's moving 2 meters. And then at the 3rd second, he's here. So now what I want to do is put an arrow on here. Well, he's not moving here and he's not moving here, so those don't get arrows. In this case, he's moving that way. In that case, he's moving that way, and that one's going to go off the paper. These are all going to be equal length because he's moving at equal speed. So let me give you one and see if you can figure this one out. I want you to put your wonderful brain to work on this one. And I want you to see if you can figure this out. Can you, in words, describe that? Think about it. We'll talk about it in class.